Hello, Tim Sandle here, and to supplement this part of the course, we're going to have a look at environmental monitoring methods and some of the limitations about the methods. So again, this is a sort of 5-minute video just touching upon some of the fundamentals of these different methods. So let's move on to the methods themselves. So just as a brief description, we have these classic methods: settle plates, active air samplers, contact plates and swabs, and particle counting using optical particle counters. There's also a raft of rapid microbiological methods coming onto the scene, like spectrophotometric particle counters. And these classic methods are well established, but they do have some limitations, and we're going to touch on some of those, and this will help support some of the other material. So let's have a look at active or volumetric air sampling. So the first thing to get across is that there are different types of air samplers. So there are, for example, impaction air samplers, where the air comes down and strikes an agar plate with force, and the idea is that the microorganisms then adhere to the agar. There is also centrifugal agars, where the air is brought in and spun round at a very fast rate to create centrifugal force, and the idea here is that the microorganisms are flung out to attach onto agar. And there's other models as well. The key thing is that air samplers work differently, and even with models based on the same design, there are differences in the efficiency. And perhaps one of the key concepts to get across is this cutoff efficiency, or what's called the D50 value. The D50 is the size at which half of the particles, and remember these are going to be carrying a number of microorganisms, so it's the size at which half of the particles are collected and half will pass through the sampler without being collected. And the smaller this size is, then the better the efficiency of the sampler, because if it's only going to lose 50% of the smaller particles, then it will collect a higher number of the larger particles, and most of these will be microorganisms. We also have to note the biological collection efficiency, which is something the manufacturer would do in a bioaerosol chamber, the effect upon media including dehydration, whether the air sampler itself disrupts the airstream, and also how we are going to calibrate the sampler as well. Okay, let's move on to settle plates. Okay, so with settle plates, these are very good at collecting organisms that will come out of the air when air slows down, hits a surface, or through gravitational displacement. But they're only useful if they're put in meaningful locations. So within unidirectional airflow devices, we can find more meaningful locations through air visualization studies. But we also need to know that the agar can function effectively in these more harsher conditions, because remember, air within unidirectional airflow devices is very fast, and it can dry out the agar quite quickly. So we need to show that the plate can be exposed for 4 hours whilst retaining its nutritive properties, and there's discussion about that in the material. And we also need to be careful that when we put plates in and out of a unidirectional airflow device, that we're avoiding cross-contamination as well. Okay, contact plates. So contact plates are good for flat surfaces, although we need to bear in mind that a contact plate on the surface is only going to pick up about 50% of the microorganisms present, and that's even after controlling the time and controlling the pressure, which are two key variables with this technique. It's also important that the agar used contains neutralizers, because we probably will have disinfectant residues on the surface that we're trying to sample. Okay, and then the final slide for this video, we're going to have a quick look at swabs. So swabs are good for irregular and very thin surfaces, or for doing vital but atypically shaped objects. So let's say we're doing aseptic processing and we have filling needles, then we need to be able to swab those. But swabs have a poorer recovery in general than contact plates, although there is a difference between plain swabs, which have the weakest recoveries, and flock swabs, which have a better recovery. So we get between the 40 to 60% recovery rate with flock swabs, as demonstrated in studies. And there's a lot of reliance with swabs on the technique. Okay, so that was an introduction to environmental monitoring techniques and to some of the weaknesses with those. So back to your reading.